Hello friends, welcome you all on my YouTube channel. In this first lecture of Module 1, we are going to talk about Introduction to Probability. When we talk about the probability, a number of words we can think in our mind. I usually ask to students, what is probability? So usually they say this is the possibility of occurrence of any event, chance of happening of any outcome, and many more. Sometimes they use the word probability as well. So in general, you can also talk about some words. So in probability, first we know the probability is what? It is like possibility of any uncertain outcome. So once we talk about possibility, it means what? We are not sure about the occurrence of any outcome or event. That's why we use the possibility. Possibly the student will pass the examination. Sachin will score century. Anything that we talk about the possibility. India will win the match. There is a possibility. It may be higher, it may be lower. That is different thing. Sometimes chance we are talking about. There is a chance it will rain today. It is raining. There is a chance I will get a job. There is a chance the salesman will sell all the product in this year. So chances what are also used in day-to-day life. So we will reconnect the probability with the day-to-day life here. Sometimes expectations are also defined in the form of possibility. We are expecting that Sohan will qualify in GATE examination. So such kind of expectation is also we talk about. Percentage, 50% chance I will get a good product from the market. So the percentage also can be defined in such a way. So in the whole cycle, we can understand in day-to-day life, we use these kind of words, possibility, chances, expectation, percentage. When we study any book of theory of probability of any good author, if you are studying, so the few examples are common that you can see in every books. Free examples means what? Few experiments that we can say are the common. Like tossing of a coin. Coin has two faces, head and tail, and either head or tail will turn when you toss a coin. On the basis of that experiment, you can frame the number of questions. Suppose we are talking about throwing a dice. So once you throw a dice, any number will come on the upper face of the dice between 1 to 6. So there is a possibility which number will come on the upper face from 1 to 6. So these are few examples that we see in the books as well. So once we talk about the probability, we usually talk about the experiment. So experiment is repeated under essential homogeneous and similar conditions. Similar conditions means what? The possibility of every outcome is equal. So in such case, we have two type of situation. Once the outcome that we know, the outcome what we get from the experiment, if it is unique and certain. Suppose the coin has both has the same face, the head. So what will happen if you toss a coin? Head will come out. That is a certain phenomena. For the dice, if all the faces are numbered with a certain number, like 1 suppose. So if you throw a dice, 1 will come out. So that phenomena that is termed as a deterministic or predictable phenomena. So the first type of experiment that we define as a deterministic or predictable, where the outcomes are already certain, already are defined, that we know the outcome. Suppose a vehicle is going from one place to another place in the straightway direction. Sometimes we are certain that vehicle will reach the destination. So we can predict the outcome with the certainty. So it is deterministic. Number of mathematical formula that you can see. So in such a way, the first type of experiment that we define, that is deterministic. So the second type that we know, which cannot be determined, which cannot be predictable. So it is a probabilistic way. So in such a way, you will talk about the probabilistic, where the uncertainty generates, like tossing of a coin. What will happen? So once we talk about the experiment, it will have two type of criteria, whether it is deterministic or it is probabilistic. Few examples that we can see for the deterministic, that the well-known, the gas constant that we know, PV is equal to constant, where V is the volume, P is the pressure. That can be predict the temperature remain the same. Once we temperature remain the same, that is considered here. So PB is equal to constant. You can for any pressure you can predict the volume. Suppose we are talking about a movement of any particle on a vehicle with the velocity or speed v. So we can predict after time, we can predict the distance, right? So if u is the initial velocity and a is the acceleration, so the equation that determines v, if the right hand equation are known. So any formula, suppose a plus b whole square, if it is known, area is known. So if you have the a, you can predict the b. So that kind of examples that you can see. So the outcome of the experiment is directly connected with the formula in the homogeneous condition, that we can treat as a deterministic phenomena. As I told you earlier, suppose a vehicle is moving from one place to another place. So what will happen? Sometimes we are certain that vehicle will reach the destination. If we are talking about certain, it means definitely it will reach the destination. Where we are not able to predict the result, outcome, in that case we know it is unpredictable or probabilistic phenomena. You can see the number of examples of unpredictable and probabilistic phenomena. In a random toss of uniform coin, that we know it has a two phase, head and tail. So uh, phase any phase will turn up, either head or tail. So that is uncertainty that comes here. You cannot predict, it is unpredictable situation or experiment. For real world example, a manufacturer cannot ascertain the future demand of his product with certainty. So if you're talking about today, suppose a salesman is there, so how much product he or she can sell for today, it is uncertain. On the basis of past experience, you can predict, but you cannot say it is certain. A sales manager cannot predict with certainty about the sales target next year. So these are the examples of unpredictable and probabilistic phenomena. So another example that you can see about the electric bulb that has lasted for 1 year, nothing can be sure about the future life of that electric bulb. So such things happens in our real world problem, real life. So these are the unpredictable experiment. So the probability is also used informally in day-to-day life. We daily come across the sentence like possibly it will rain today, right? Possibly the sun will rise in a good manner. There may be fog, possibly. There is a high chance of my getting the job next month. I told earlier that we can uh, not be certain. It is an uncertain phenomena, unpredictable phenomena. This year, demand of the product is likely to exceed that of the last years. It is also one example of the uncertain. The odds are 3:2 in favor of getting the contract applied for. So number of examples that you can see. So what happened here? We have bifurcated the real world phenomena into two parts. One is predictable, another is unpredictable. One is certain, other is uncertain phenomena. Where the outcome is definite, that will come, but we are sure, but in another way, the outcome are not sure. So in one sentence, if we talk about the probability, so it is the what? Probability is the science of decision making with calculated risk in the face of uncertainty. In other words, in general words, you can say the mathematical expression of the possibility is known as probability. Mathematical expression of the possibility, possibility chance, that is defined as a probability. Now some basic terminology that we can define here. So as I told you earlier, the random experiment. Random experiment is what? The trial of an experiment that is conducted under identical condition where the outcome is not unique, but it may be one of the possible outcome. We are not sure about the outcome. That is, such type of experiment is known as random experiment. So unpredictable experiment, that we talk about the random experiment. You have number of example again: tossing of a coin, throwing a dice, selecting a card from a pack of playing card, selecting a family out of a given group of families, secondly selecting a colorful balls from the earth. So these are the few examples, well-known examples that you can see in different books as well. Once we talk about the playing card, that we know, those who knows to play a playing card, they are aware about this. So four type of cards that you can see in the pack of playing card: spade, hearts, diamonds, and a club. Each card has the 13 different cards. Out of these, 9 are the numbered card, 2 to 10, and one ace, king, queen, and jack. Spade are the black face color, while the heart and diamonds are the red face. Spade and the clubs are the black. So these are the general information about the playing card. So once the experiment performed, you know, some result that comes, that is termed as an outcome. So outcome is a result of the random experiment. Under the terms that we define trial and event, so any particular performance of a random experiment is called a trial or outcome, or combination of outcome are termed as events. Suppose you are talking about the throwing a dice. So what happens? Any 1 to 6 number make turn on the upper face of the dice. So if you're talking about the even number comes, so the collection of that number 2, 4, 6, that termed as an event. You can predict, you can say the odd number, less than 3 number, greater than equals to 3 number. So in your way, you can define the outcome as an event. So event is what? It is a group of possible or favorable outcomes. Event is what? It is a collection of all favorable outcomes. Suppose you are talking about the even number, so 2, 4, 6 is your favorable outcome. So if you are tossing a coin, if you say head comes, so head is your favorable outcome. If you are tossing a 2 coin and you are saying that the 2 head comes, so you know the only one possibility that head comes on the both coin. Otherwise, head, tail, tail, head, and the tail, tail, that we define. So before that, if I miss some word, that is the sample space. Sample space is what? It is a set of all possible outcomes. So if you are tossing a coin head and tail, by making the set of head and tail HT, that we define in the form of sample space. If you're talking about the throwing a dice, so all numbers 1, 2, 3, 4, 5, 6 makes a set, and that is the word sample space. That is the all possible outcomes that you can see. Now come to the next one, that is exhaustive events or cases. The total number of possible outcomes of a random experiment is known as exhaustive events or cases. So exhaustive is also that is termed as a sample space, but once we talk about the event, so any two events are said to be exhaustive if their union is sample space. So that's why it is exhaustive events. For an example, if you are tossing a coin, there are two exhaustive cases, head and tail. That is the word. Union of head and tail makes the sample space. If you throw a dice 1 to 6 number, that makes the these are the exhaustive cases, and that makes the sample space. So these are the a few examples that you can read and study from books also. Suppose you are throwing two dice, so exhaustive number of cases will be 36. So any number 1 to 6 will come on the first die, and the same 1 to 6 on the second dice. In that case, the combination of 1 to 6, 1 to 6, that makes the 36 combination. If you are talking about n number of dice, so it is 6 to the power n, that we can see. It is not 6n, it is 6 to the power n. For 3 dices, it will be 6 into 6 into 6, 216 number of exhaustive cases that you can see in the form of sample space. So the favorable event or cases that we know, we talk about the event. Suppose you are going for the finding the probability of particular event. So event is what? It is a set of all favorable outcomes of a random experiment. In a draw of a card from a pack of cards, the number of cases favorable to drawing an ace is 4. The full number of aces are in the playing card, and drawing a spade in 13 is 13, and drawing a red card is 26. In such a way, we can define the event. If you are throwing a dice and you are talking that it is an even number comes out, so 2, 4, 6, the set of 2, 4, 6 number is defined as an event or favorable outcomes. So two dice are there. If the number of cases favorable to getting the sum 5, so the favorable outcomes can be 4, 1, 1, 4, 2, 3, 3, 2. That is the total number of 4 favorable outcomes, and once you define as a set, it is event for the random experiment. Now it is very good terms usually we discuss in the class. So mutually exclusive events. So events are said to be mutually exclusive or incompatible if the happening of any one of them deny or precludes the happening of all the others. So if you can understand by example, if you're tossing a coin, so what happens? Either head will come or tail will come. If head comes, that there is a zero possibility that tail will come. So it alters the possibility of any other events. Suppose you are throwing a dice, so what will happen? Either 1 to 6 number will turn up. So all 1 to 6 are the mutually exclusive. So by ruled out all the outcome that we define mutually exclusive events. As I told you earlier, tossing a coin, the event head and tail are the mutually exclusive. The outcome head ruled out to turn tail. Now equally likely events. So outcome of a trial are said to be equally likely if taking into consideration all the relevant evidence. There is no reason to expect one in preference to the others. Suppose you are tossing a coin, so head and tail both have the same possibility to turn, so it is equally likely. But if it is unbiased, uniform, then if it is biased, so it is not equally likely. If you are throwing a dice, if number are written 1 to 6 on the each faces, then it is equally likely. But one comes 2 times, or any rest 4 numbers are there, so it is not equally likely. In throwing an unbiased die, all 6 faces are the equally likely outcomes, as I told. Now the term that define it is independent events. So I will discuss the independent events later also mathematically, but once here for the definition point of view that we can discuss here. The several events are said to be independent if the happening of an event is not affected by the supplementary knowledge concerning the occurrence of any number of the remaining events. So independent events are, suppose you are talking about the two different events, these are said to be independent if they are not affecting each other. If they are not affecting each other. Suppose tossing an unbiased coin. So whenever we say the coin, it is unbiased. Consider now it is unbiased. So tossing an unbiased coin, the event of getting ahead is in the first toss is independent of getting ahead in the second, third, or any other subsequent throws. So this is a very good example of independent events. When a die is thrown twice, the result of the first throw is independent from getting on the second throw. So these things that you can understand, the possibility of qualifying the examination of one student is independent for the others also. So for today, uh, we end with this basic terminology of the probability. If I missed it, any words, you can write in the comment box. Definitely I will include in the upcoming videos as well. So once again, thank you all for being with us. You can subscribe our channel. You can comment on the comment box. If you have any query, you can comment on the comment box. Once again, thank you. Thank you for watching this video.